Hi everyone, hope you are all fine. Today we will be dealing with a new chapter, that is surface chemistry. Okay, so chemical kinetics is over. Now we are going into a new chapter, that is surface chemistry. Okay, now when we talk about surface chemistry, the name itself tells that it is the chemistry of surface, or the chemistry which is lying behind on the surface of this solids or liquids or gases. Okay, that means the surface chemistry deals between the interface of solids or liquids or solids or gas or solids, etc. Okay, what do you mean interface? What is interface? Interface means the boundary between, if you take an example of a solid and gas. Okay, for you we are only concentrating on solid and gas. Okay, so if there is a solid, okay, if there is a solid plus there is a gas, okay, you will say the interface between the solid and the gas, the study about that, the study in connection with that is called as surface chemistry. Okay, now how will you go for, how will you write this? If a solid and gas is there, you will write the interface as a hyphen, that is solid hyphen gas, or you will write it as solid slash gas, which means that you are studying something with interface between the solid or gas. Okay, but if you talk about gas and gas, there is no interface. Okay, so there is no surface chemistry behind that gas and gas interface. Okay, so that is the meaning of the interface between the two. Or if you want to have an interface example, while you are studying solutions, okay, solutions we are studying the first chapter, there we talked about crystallization and dissolution. Are you remembering that? In that case also, what happens? We have talked about the rate of dissolution is equal to the rate of crystallization, isn't it? In that case, the interface between the gas and liquids is in the picture of that. Okay, so that is meant by interface. Okay, now when we say an example of surface chemistry, if you want to talk about an example of surface chemistry, the best example is corrosion. Just to think about what is corrosion or what is happening in the corrosion. Corrosion means corroding of metals. For example, if you take rust. Now how the rust is corroded? You have a metallic iron, isn't it? That's a solid. Okay, then what is happening? The air molecules, the water molecules or water vapor or air will attack into this iron, isn't it? And it tends to corrode. So what is the chemistry behind it? That is, the reaction is taking place at the surface, isn't it? It is not going into bulk into that iron metal. No, it is only the reaction, or the reaction is happening only on the surface of the iron metal. So that's the best example of surface chemistry or surface reaction. Okay, or another example we have studied in the third chapter, that is electrochemistry, isn't it? Do you know what is the example there? Yes, the electrode, isn't it? You are having two electrodes, the positive and the negative. Now what is this electrode meant for? It gives the surface area for the reactant to react, isn't it? Okay, even in sheet, that is standard hydrogen electrode, the platinized platinum acts as an electrode, correct? Now what is the chemical reaction taking place? The platinum metal, that means a solid, and as a surface, isn't it? And the gas is absorbed in the hydrogen gas is absorbed in or hydrogen molecule is absorbed in this platinum metal. So that is just an example for a surface reactions. Or so many examples are there. Which I told you, the dissolution, the crystallization, then the heterogeneous catalysis that you will study later, or the corrosion, etc. are the examples of surface reaction. So surface chemistry. Okay. Now, while dealing more with surface chemistry, you know, the reactions is happening on the surface. Now for example, if we have a solid gas, we have a solid surface. Okay, solid surface. Here, the molecules are getting into the surface of the metal, isn't it? Surface of the metal. Okay. Now, if a reaction has to happen in the surface of a solid, for example, if you are taking solid gas example, that metallic surface must be very, very clean. That is very important. You know, because when some metals are exposed to air, corrosion happens, for example, iron, okay, nickel, etc. So, in that case, in order to study meticulously the surface chemistry, the solid surface must be very, very clean. Now, how you will make that surface clean? You will vacuum it. Okay, you will vacuum it with the power 10 to the power -3 to -5. So, extra cleaning of that metallic surface is done by vacuum. Okay, then only the metals will be very, very clean. Then only the molecules are taken into the surface of the metals and the reaction happens. Okay, that is just an introduction for the surface chemistry. Okay, now when talking about the application of surface chemistry, there are so many applications. There are analytical applications in surface chemistry, or simply I can say there is a day-to-day life application also in surface chemistry. And the best example is the cleansing action of soap. We have studied in 10th standard the cleansing action of soap, the meshes, isn't it? The formation of meshes. Okay. Now in this chapter also we will study in detail about the cleansing action. So that itself, the soap itself is called as surfactants. Okay. The soap itself is called as surfactants. Okay. So that is dealing with the surface of the molecules. Okay. So that is day-to-day life applications are there. Okay. So this is all about an introduction of surface chemistry, and now you know what is surface chemistry? The reactions which happening on the surface. Okay. It can all happen in solids, liquids and gases, but our interest is what? Mainly we are dealing with solid and gas. Okay. That means the gas molecules are on the surface of the solid substance. So is it clear? Okay, that is about the surface chemistry. Okay, now going into more detail, we will see what is exactly surface chemistry, or how these gas molecules, when we talk about solid gas interface, how these gas molecules are coming and sitting on the surface of the solid substance. Is there any force of attraction between them, or what is the mechanism behind it, or what is the reaction, or is there any reaction happening between the surface molecule and the solid substance? So that we will see this chapter. Okay, so going on to the detail of the surface chemistry, there is one important term. In fact, two important terminologies are there in surface chemistry. Okay, the first important term is, now actually the mechanism, how it happens is called as adsorption. What is it? Adsorption. Adsorption. Okay. Adsorption. Now, adsorption is the mechanism by which the surface chemistry happens. Or, in other words, I can say, if I say a gas molecule is sitting on the surface of a metal, what is the mechanism behind that? If you ask me, I will say, it is due to the adsorption of gas molecules on the solid surface. Okay, for example, if I have a solid substance here, say, imagine a solid substance, and imagine gas is sitting on the surface of the metal or a solid substance. So here it is the gas. Okay. Now what I will say, this gas molecule is adsorbed. See, adsorbed on the surface of the solid substance or a metal, for example, a metal. So that is called as adsorption. Okay. Now adsorption means what? The molecules, gas or liquid, whatever be it, the molecules are accumulated where? Accumulated on the surface of the substance. Okay. The molecules are not going into the bulk. It is not going inside it. It is only on the surface of the solid substance. So that is called as an adsorption. Very, very important. Okay. Or in one word, I can tell, adsorption is nothing but absorption on the surface. Again, another terminology which is called as adsorption. See, this is AB and it is AD. So in one sentence I can say that adsorption is nothing but absorption on the surface. Clear? Adsorption means absorption only on the surface of a solid substance or a metal. That is called as adsorption. Okay. Or I can give an analogy for absorption as evaporation. Just an analogy, right? Just an analogy. We will say evaporation is a surface phenomenon. Why? Because from the surface the molecules are getting evaporated. Correct? Isn't it? Below the boiling point. But there is also an analogy for absorption. What is it? Boiling. Just to make you understand, that's it. To make you clear. Okay. So you say, you have studied, that's why I am taking this analogy. Evaporation is a surface phenomenon and boiling is a bulkier phenomenon. Exactly the same thing is happening here. That is, adsorption is a surface phenomenon whereas absorption is a bulkier phenomenon. Now you got this difference between what is adsorption and what is absorption. Adsorption means the molecules are only accumulated or concentrated on the surface of the solid substance. Okay, but in the case of absorption, what happens? The molecules will get into the substance, isn't it? Into the bulk of the substance, inside the substance. So there we call it as absorption and the surface phenomenon is called as adsorption. Now it is clear. These two terminologies, that is adsorption as well as absorption. Adsorption is nothing but absorption on the surface. You can just simply say absorption, okay, absorption on the surface, absorption on the surface is called as what? Adsorption. In a simple way. So you got this concept clear? Simple. It is adsorption and absorption. Just to think about evaporation and boiling. One is a surface phenomena, other is a bulkier phenomena. Okay, is it clear? Now we will move on to next two terminologies which is very, very important. Okay, without this you cannot go further into the surface chemistry. Okay, the terminologies which we usually come across with. The first is two terms. One is absorbent. Okay, absorbent, and the second is absorbate. See, these are the two terminologies which you come across in surface chemistry. Okay, what is absorbent? I'll give you an example. See, if there is a metallic surface, there is a solid metallic surface. For example, nickel metal. Okay, in this solid substance, you know, hydrogen gas. What is it? Hydrogen gas are absorbed on the surface of this nickel metal. So here I am drawing the hydrogen gas at the surface of the metal. If I am drawing this, I can only draw like this. If I want like this, the surface, the hydrogen gas are absorbed. Absorbed means only on the surface, not in the bulk, right? Okay, so only on the surface the hydrogen gas is getting absorbed. If this is the scenario, I can say the solid nickel is the absorbent. What is it? Solid nickel or the metallic surface or the substance in which anything is getting absorbed. If it is a gas, well, we can say the solid substance in which the gas is getting absorbed is called as absorbent. Correct? Now here, what is the absorbent? The solid metal or solid substance. Okay. Clear? Now, what about absorbate? Absorbate means the gas which is absorbed on the surface of the absorbent. Clear? Absorbate is the gas. Here we are considering gas. Okay, solution or liquid also you can consider. But in this case we are considering nickel and hydrogen gas. Okay. Now what is the absorbate here? Hydrogen is the absorbate. Why? Because it is getting absorbed on the solid substance. So what is getting absorbed is called as adsorbate, and on which surface it is getting adsorbed is called as adsorbent. Clear? Now, for example, if I say one example, or if I say, you have seen the sponge, isn't it? Sponge, you have seen the sponge. Now in that case, if I say, what is the adsorbent? I will say that sponge, that solid sponge is the adsorbent. And what is the adsorbate in that sponge? There are so many holes in the tiny pores in the sponge where the gas is getting absorbed into it. So in that case, I can say the air is the adsorbate and the sponge, that is the rubber thing, is the adsorbate. The form, the rubber form thing is the adsorbent. Correct? Now you know the difference between adsorbate as well as adsorbent. Okay, clear? So that is all the absorbent as well as the adsorbate. Okay, now we will see some examples of a good adsorbent. What is adsorbent? The substance in which something is getting adsorbed. Okay, the best example is, you know, silica gel. Have you heard of silica gel? What is silica gel? Have you heard of silica gel? That is, when you purchase a new bag or a suitcase in leather or other format, in that thing there is one small thing which it is written as silica gel. Correct? Okay, now what is that for? That silica gel, it is written there. It is written that it is not for you, don't swallow it. Okay, so this is only for the this purpose. Okay, what it will do? That is, if the silica gel is put in a leather bag or any other bag like that, a new one, there is a possibility of moisture inside this bags. Okay, leather items and all, and it will get fungus. Okay, so in order to remove that moisture, you will put that small packet of silica gel. Now what the silica gel will do? This silica gel will absorb. Take a note on that. It will absorb, not absorb. Absorb means fully. For example, for absorption we will say the plant absorbs water from the soil. That is absorption. Fully it is taking into the bulk of that plant. It is going up, isn't it? Through inside the plant. Here what happens? The silica gel is absorbed. The moisture is absorbed. That means absorption that is only taking place on the surface. Okay. So, and exactly what is silica gel? Silica gel means if you feel that silica gel, you will see small granules inside that. Small granules, isn't it? Small granules of silica. Okay, just for information. Small granules of SiO2, silica. From silica hydrate. That you will study later. So small granules of what? Silica, that is silicon dioxide. Okay, so it has the capability of what? To absorb the moisture and thereby preventing the fungus. So that is why we put silica gel inside this leather bags and all. Okay, so that is one of the example of a good absorbent. It's a very good absorbent. Okay, now second example you can say it as the same as silica gel. You can have one more example as alumina gel. Okay, alumina gel. Okay. So this is mainly what? Sodium aluminum silicate. From that you will get this silica gel, alumina gel. And the common absorber which you find in daily life is what? Is charcoal. Have you heard of charcoal? Charcoal, the black one, the carbon. Yeah, charcoal is a very good absorber. You know it, right? You have seen in TV ads, like when the charcoal is put in a muddy water, then all of a sudden the muddy water will become very clean water. What do you mean by that? Which means that all the impurities are absorbed by the charcoal, and thereby you will get the pure water. So charcoal is a very good absorbent. Absorbent means it's a good absorber. Okay. Now in charcoal you have two types of charcoals. Charcoal means it's a simple charcoal, that is a carbon. Okay, simple charcoal. Now there are two types of charcoal which act as a very good adsorbent. One is activated charcoal. Have you heard of it? Yes, you have studied in 8th standard, purification of water. Okay. And second is activated charcoal, and second is animal charcoal. See, charcoal is there, right? It will absorb. It's a very good adsorbent. But rather, activated charcoal is a very, very good adsorbent. It can very well absorb even the minutest impurities. Okay. So this activated charcoal, and how this activated charcoal is formed? That is, when this charcoal is heated to a very high temperature, you will get activated charcoal. Okay, that's all. So activated charcoal is also an example of a good adsorbent. Name it adsorbent. AD. Okay. Now what is animal charcoal? Have you heard of animal charcoal? Yeah? Or it is called as char bone or bone char. Anything. Bone char. You know how this animal charcoal is produced, or how do we get this animal charcoal? That is by calcinizing the bones of animals. Calcinizing means what? Calcination. Calcination means in absence of air, strong heating. On strong heating of these animal bones, you know animals, right? Yeah, animal bones, or you can say at the destructive distillation of animal bones, you will get what? You will get the animal charcoal or bone char. Okay. Okay. So this is about the charcoal or good adsorbent. Okay. So examples are what? Sometimes a 1 mark question can ask you an example of a good adsorbent. So you can say silica gel, alumina, charcoal, etc. Are good examples of what? Good. And also one more thing. Finely divided metals. Most commonly, finely divided metals. Okay. What do you mean by finely divided metals? For example, finely divided iron. It is a very, very good adsorbent. Why you say finely divided? What is the peculiarity of a finely divided case? Yes, we know. Isn't it? What? In finely divided case, the surface area is increased or more than the other one. So, since the surface area is more, the extent of adsorption is also more. That is, more place is long. Isn't it? So, the extent of adsorption depends on, what is the extent of adsorption? The number of molecules getting absorbed. That is extent. So, the extent of adsorption depends on, very, very important, it depends on the surface area. Isn't it? Surface area. Why? Because surface area means what? It is the outermost layer. The interface is surface area. Isn't it? So, if the surface area is increased or if the surface area is large, then the extent of adsorption is also large. That means more and more molecules can get adsorbed on the surface of the solid substance. Is it clear? So these are the examples. Finely divided metal, silica gel, aluminium gel, charcoal, etc. are the examples of a good adsorbent. So is it clear till now? Okay, just 4 terminologies: adsorption, absorption, adsorbent, and adsorbate. If you want an analogy for an adsorbent and adsorbate, we can say the solvent. It's not a real thing, just an analogy. The solvent, that is a bigger one, is called as an adsorbent, and the adsorbate, that means something is getting. Now, or you can say a good example is colloid, the dispersed phase and the dispersion medium. Isn't it? The dispersion medium is the adsorbent, and the dispersed phase on which it is getting into it is called as adsorbate. Okay, a very good example is in colloids, the dispersed phase and the dispersion medium. Okay, now we are clear with that, right? The 4 terminologies. Now we move on to some of the day-to-day actions where the adsorption takes place. Some of the things where adsorption, the common things or the common areas where the adsorption takes place. Okay, where you can find this adsorption in your day-to-day life. Okay. Now the first is, as I already told you about the silica gel. Okay. Silica gel means what? It will absorb the moisture. Very important, not absorb, it will absorb the moisture. Okay. Now the second thing we see in the daily life is, if you have, for example, if you have a container, and you put so many gases, for example, hydrogen, chlorine, ammonia, then sulfur dioxide, etc. Okay, if you have this, and if you put a charcoal, carbon, an activated charcoal into it, what happens is, the pressure of this gas molecules will be decreased. Why the pressure of these gas molecules get decreased? Why? Because since activated charcoal, or charcoal is a very good absorbent, some of the gases will get absorbed into this charcoal. Thereby the pressure is decreased. If you look into the pressure of the container, the gas molecules, the pressure of the gas molecules is decreased. Okay, so that is again an example for an absorption taking place. Okay, so the gas molecules, the pressure is being decreased in the gas molecules. Just an example, that's all. The pressure of the gas is decreased. In a container where so many gases are there, when you put an activated charcoal, it will get absorbed. That's all, a simple one. And now third one. When you talk about sugar, what is sugar? You know. Okay, you are having daily, isn't it? Sugar in tea or coffee or whatever. Now, that sugar, what is its color? It is very, very white in color. You will say sugar is poisonous, right? Okay. So, actually, if you are a biology student, you know from where you will get the sugar. From molasses. What is molasses? The sugar cane syrup, isn't it? The sucrose, that is the sucrose, when you have this distillation and all, you will get the molasses. Okay. Now this molasses is what? Brown in color. Okay. Actually, that raw sugar is brownish in color. Now how this brown color is now converted into this whitish color, pure white color? That is, this is also due to absorption. Now how it takes place? When this brown color of sugar is passed through animal charcoal, when it is passed over a bed of animal charcoal, what will happen? The color, the brown color is absorbed by the animal charcoal, and thereby you will get the white color. You got it? That is, again, absorption is in action. Okay, so that is why you will get the white color of the sugar. Okay, now one more example if you want. You know dyes are what? Mixture of colors. Okay, now for example, methylene blue, you have in your lab, blue color. Now in this methylene blue, if you put an animal charcoal, what will happen? The blue color is getting absorbed, meaning absorbed, and it will form a colorless solution. See? So just some examples of absorptions which you are seeing in our daily life, or where the absorption is taking place. That's all. Okay, just to have an outlook of what an absorption is. Just to have a hang of it. Okay, so that is clear. Okay, now what are we studying? Absorption, absorbent, absorbate, and some of the examples. Okay. Is it clear? So this is a very good chapter. Why? Because there is no numericals in it. Only theory. Okay, theory is there. So it is very good to score mark also. Okay, it's a very small chapter also. Now we will see what is exactly absorption. Okay, what is exactly absorption and absorption? We can distinguish between absorption and absorption. See, how will you distinguish between absorption and absorption? We already stated this, but still. What will you say? What is absorption? In one word you can say. What? It is a surface phenomenon. Isn't it? It is simply a surface phenomenon. Okay. Now, what is absorption? Absorption is a bulkier phenomenon. Isn't it? It is a bulkier phenomenon. Absorption is a surface phenomenon. Okay, in the case of adsorption, what will happen? The molecules are getting accumulated on the surface of that substance, solid substance if I say. But absorption means what? The molecules are getting inside the substance, in the bulk of the substance. So that is the main difference between absorption as well as adsorption. It's a surface phenomena, where this is a bulkier phenomena. Okay. For a simple example, if I say, you have a chalk piece, right? You have a chalk piece, white chalk piece if you have. And if you dip in an ink solution, if you dip the chalk piece in an ink, what happens? The surface of the chalk piece color is, if you say blue color, the surface of the chalk piece is blue, isn't it? There you can say, what is the phenomenon taking place? It is adsorption. Why? Because at the surface of the chalk piece, there is a blue color. Or the blue color means it's a dye, correct? Dye. So that adsorbate is getting, on the surface of the chalk piece. Okay. But again, if you break the chalk piece and see inside, what will you see? Inside also what happens? There is a blue color. And in the center you will have a small whitish color. Isn't it? You have experienced it, right? Now what this says, in this chalk piece, adsorption is anyway there because the surface is blue. But inside the chalk piece also there is blue color, which means that in the chalk piece, what happens? Both absorption as well as adsorption takes place simultaneously. There can be also like that. Adsorption and absorption takes place simultaneously in this chalk piece case. So such a case, we can say it is called as sorption. See, it is neither ad or up, it is simply sorption. What is sorption? Sorption means both adsorption as well as both adsorption as well as absorption takes place. So in that case, we call that process to be what? That process to be sorption. Got it? So what is sorption? Both adsorption as well as adsorption takes place simultaneously is called as sorption. Okay. Now one more thing. We said some gas molecules are getting absorbed on a metallic surface or a metal surface. Okay. Then we call that phenomenon as adsorption. Correct? Now, what will you call if the gas molecules are relieved from that metallic surface? Relieved means get away by applying say temperature. If you heat it, the gas molecules are getting relieved from or get out from that surface molecule, surface of this substance. Now, what is that phenomenon called? It is called as desorption because it is going away. Okay, so coming is adsorption, going away is desorption. Okay, there is one more thing, you call it as desorption. Okay, so this is a theoretical subject. Okay, theoretical class, so you have to talk a lot about this surface chemistry. Okay, so you got it. What is adsorption? Surface phenomena. What is adsorption? What is adsorption? Surface phenomena. What is adsorption? Bulkier phenomena. What is sorption? Adsorption takes place simultaneously. Now what is desorption? The phenomenon by which the adsorbed material gets away from the solid substance. So that is called as desorption. Okay. Now one more example if I want to tell is, have you heard of anhydrous calcium chloride? Have you heard of anhydrous calcium chloride? What is it? It acts as a deliquescent. What is a deliquescent? Deliquescent means a substance which absorbs moisture. Correct. A deliquescent means a substance which absorbs moisture. Absorbs. What I am talking? Absorbs. Correct. Absorbs. Okay. So when calcium chloride is used, the water molecules or water vapor will be absorbed by the calcium chloride crystals. That is why it is called as deliquescent. You have studied, isn't it? Deliquescent and efflorescent. So deliquescent means what? It will absorb the water molecules or water vapor. But what about in the silica gel? You know. What about in silica gel? The silica gel will only absorb the water molecules. See the difference? Same thing. The water. Water is the absorbate. What are the absorbent? If the absorbent is calcium chloride, absorption takes place. Okay. Now, if the water molecule, if the silica gel is the adsorbent, what happens? It is absorbed. That is the differentiation between adsorption as well as absorption. You got it? It is simple. Just to make you understand, to make it clear. That's what this adsorption and then absorption. Okay. Clear? Now we will move on to the very, very important thing, that is the mechanism of absorption. Okay, this much is, you know everything. Okay, just I make a recap of that. You know what is absorption from the smaller classes, evaporation is a surface phenomena like that. I said absorption is an absorption surface phenomena like that. Now coming to the mechanism, which is very, very important. Okay, now we will see how, you see, we said or we talked about a gas molecule is getting absorbed on a solid surface. Okay. Now the question is, how this gas molecule is getting absorbed on a solid surface, and also why this gas molecule is getting absorbed. There are two questions. Okay. How the gas molecule is getting absorbed? You know, some force of attraction will be there. Definitely it will be there, isn't it? Without the force of attraction, a molecule cannot be attached to another surface, isn't it? Okay, well. Now the second thing is, why it is getting absorbed, or why the surface molecule is attracting the gas molecules to get absorbed on this surface. So that comes the mechanism of this surface chemistry or absorption. Okay, now we will see what it is. Okay, it's very important. Board exam questions are asked. Okay, so we listen very, very carefully. Okay, now if I talk about mechanism, okay, mechanism is, see, you know what is absorption? That is absorption on the surface. Now if for example say, I have a adsorbent. Now I only talk about adsorbent and adsorbate. You know the difference, correct? Okay. Now if I take an adsorbent, say a solid substance or a metal. Okay. Metal for example, say nickel. Okay. Say nickel. Now what happens? Some gas molecules are absorbed on it. Correct? Now for your convenience, I will draw only one gas molecule. One hydrogen gas is absorbed on this metallic surface. Correct? Now here also there are molecules. Inside this also there are molecules. Isn't it? Inside also there are molecules in the metal or in solid substances. Isn't it? Now what happens is, see, now if you see this particle, okay, this particle inside this substance, in this particle, this particle is balanced by this force. That is, these particles are balanced by some other particle in this side. This is balanced by some other particle in this side. And downward also there are particles which are balanced, this thing, and upward also it is balanced. So inside this, the particle is very balanced situation. Okay, so well balanced means what? Well balanced means this particle is balanced by the neighboring particles, isn't it? The force of attraction. This is also the neighboring particle, that is force of attraction will be there. Okay, that is stable. So here also and here also. So there is a well balanced thing inside the particle. Listen carefully. Okay, that means balanced forces are there. Very, very important. Balanced forces are there inside a solid substance. Correct? Balanced force means what? The particles are stable. Correct? Listen, very, very important. The particles are stable because there is no instability there. From every position, forces are there which equally nullifies and take the molecule stable. Correct? Now stable means what? Energy is less. Correct? Energy is less. That is stable. More stable, less energy. Clear? So inside the substance, the particle inside will have a well-balanced force between the particles. Listen. Well-balanced force between the particles. Correct? Upside, down, parallel, this side, that side, everything it is well-balanced, which means it is stable. Now, consider this thing. In this scenario, if you consider a molecule at the surface, see, if this molecule is at the surface, this is in the interior, but now what about in this case, the force between the particles? This side, okay, it is balanced. This side, well, it is balanced. And in the downward side, it is also balanced. But what happens in the upward side? There is no molecules, so there is no particles to balance with. There is no force of attraction between the particles to balance with. Do you got it? That is, here, when compared to a particle inside the substance, the particle at the surface of the at this solid substance, I am not talking about the adsorbate, I am not talking about the hydrogen which is coming, no. I am talking about the surface molecules here on the surface of the metal. Correct? Now what happens? Here there exists an unbalanced force, isn't it? Because there is no force going up. So here, very important, the value point is that here it exists what? An unbalanced, or you can say a residual force. Okay, an unbalanced residual force is there in this particle. Okay. Now what will happen? When you talk about an unbalanced force, the molecule is unstable, isn't it? When we talk about a balanced force, we said the molecule is stable. Now if there is an unbalanced residual force at the surface of the metal, then I can say this molecule is less stable. Now what will this molecule will do? The molecule wants to be stable. Isn't it? That is a natural phenomenon. Everything wants to get stable. Isn't it? So, you know that elements, molecules, that's why they react. Why the elements and molecules react each other, or why chemical reactions happens in order to form stability. Isn't it? So, in nature itself, it is the law. So, what happens? In this, for making this molecule stable, what will happen? It will attract this hydrogen gas. Isn't it? If the hydrogen gas is coming near, if you want to get absorbed, this molecule will get attract or will get a force of attraction between this adsorbate and the adsorbent. The value point. There is a force of attraction between the adsorbate and the adsorbent. And whenever there is a force of attraction or a linkage happening between the adsorbent and the adsorbate, then heat energy is evolved. Very important. That's a very important value point. That is, whenever there is a force of attraction between the adsorbate and the adsorbent, then a heat energy is evolved. Which means that adsorption is an exothermic process. Board exam question is, adsorption is an exothermic process. Exothermic. What do you mean by exothermic? Exothermic means heat is evolved. Right. Now, why the heat is evolved? Due to the force of attraction. That is why, that is the mechanism, or that is the reason why this molecule has a tendency, why this molecule has got a tendency to attract, or that is why the adsorption takes place. Isn't it? Since this molecule wants to become stable, or this molecule wants a balanced force, because it is an unbalanced residual force. So, in order to decrease the unbalanced residual force, or in order to decrease the surface energy, the energy is decreased. So that is why you will say the adsorption is an exothermic process. Very important. Repeated CBSE board exam question. Adsorption is an exothermic process. Account for it. Two value points. One is what? One is adsorption is an exothermic process. Why? Because first is the decrease in the surface energy. Just note it down. Very, very important. 2 points. Just 2 points. One is decrease in surface energy. Decrease in surface energy. Okay. Now what is second point? Decrease in residual force or decrease in unbalanced force, or I can write it as residual force. So this is, now you got the mechanism. Why it is absorbed? It is always an exothermic process. Correct. So now that is very, very important. Now just one more topic, that is we want to thermodynamically prove that absorption is an exothermic process. Okay. So now is it clear why it happens? The value point is decrease in surface energy. Energy should be decreased, that is why it is more stable. Okay. Then why? Force of attraction. Heat energy is liberated, that is exothermic process. Correct? Okay. Now we will move on to thermodynamics. Okay. In thermodynamics it states that, what is it? Delta G is equal to delta H minus T delta S. See? Delta G is equal to delta H minus T delta S. Now what is delta G? Delta G is Gibbs free energy. Isn't it? Now what is delta H? That is enthalpy. Now we talked about enthalpy, right? We talked about the heat of absorption is an exothermic process. That means definitely it is a negative value. Correct? It is a negative value. Okay. Now what is T at constant temperature? Constant temperature. And what is S? It is entropy. Now we will see this. Now what is entropy? Entropy is disorderness. Okay. Now what happens to entropy? The entropy means, see, if a gas molecule is getting absorbed, the randomness is decreased, isn't it? The gas molecule is attracted to the molecule. So if the randomness decreases, thereby the entropy decreases. So what I want to say is delta S is also negative because entropy is decreasing. Delta H is also negative because exothermic, isn't it? So we say a reaction to be spontaneous, thermodynamics. A reaction to be spontaneous, the delta G will be negative, or the delta G should be negative. Now when this delta G will be negative? By this equation. If the delta H is more negative and this is positive, then you can say this reaction is spontaneous. That's all. You know, that is, if delta G is negative means a spontaneous reaction happens. Now if a spontaneous reaction happens, the totality of this equation comes to be negative. For that, the delta H must be more negative than the delta S, or this must be positive and this must be negative. Then only a reaction is spontaneous. And after some time, what will happen? The delta H will become more and more negative and it becomes equal to this T delta S. And what is the condition? Equilibrium is attained. Okay, so you got it? What the thermodynamics you got it? It is simple. This equation you put it. If you want to get negative, this should be negative. And you know delta H is negative. That's all. Okay. So just go through the book. Any difficulty in understanding this mechanism, just give a call or just get back to me. I will clear for you. Okay. So till now, that's it. Thank you.